Thanks so much for joining me, Ali, on the Incubator Show. And yeah, I'm really excited to hear more about you and what you're building at Enerbund. So yeah, thanks for coming on.
Hello, Anson. Thank you very much for arranging this. This is very exciting, and I'm happy to be here.
All right, so tell me first about, yeah, what is your background? What research are you doing? And yeah, how did Enerbund start?
Sure. Yeah, I'm electrical engineering engineer. Uh, uh, I've done my bachelor in electronics and then my master's in control systems.
Mm,
I did the first startup company after my master's, building advanced monitoring and power analyzers for power systems.
what was it called?
It was Behin and Niru. It was a high-tech company that would try to automate the acquisition systems in power systems.
Uh-huh.
And at the time, the new technologies, FPGAs, were new, so we tried to use it to make it very compact, very accurate, and the company is still running. It's been like 25 years, I guess. But yeah, it was a good start for me.
Your
In
introduction to entrepreneurship.
Yes,
Yeah.
exactly. So after that, um, I thought that this power systems and energy systems is a very new area, and it was just starting to grow. It was 2001, two that we started thinking about all the applications that are coming up in the area in that um, around that research and also industry applications. So to cover that, I went to Queen's University and started my PhD in power electronics. With my background, which was hardware design from that company, and also control systems and electronics, uh, I needed more knowledge in power topologies, conversions, and all those energy management systems that I gained in my PhD. But my vision was always finding the right applications and spending the research time and energy and resources toward a real problem because of my industry background.
Yeah, that makes sense. So then you finished your PhD at Queen's, and then what happened after that?
So at Queen's University, my PhD thesis, I was able to actually solve another real problem for PV systems, solar panels. At the time, they were mostly connected in series to build a big voltage and then some central energy conversion you would need to connect to the grid. There was another concept that you could use smaller inverters in the back of each PV panel and directly go to the grid. But the challenge was the lifetime because these small units of energy conversion systems they all exposed into very harsh environment
Yeah.
on the roof, and their lifetime would be very limited. So I was able to use advanced control background and hardware design to remove that bottleneck, which was a component in the system, electric capacitor, and design it in a new way that we were able to extend the lifetime to 25 years, which would match the PV panels.
Wow.
Based on that, we started a company out of Queen's University with my supervisor, and the company was very successful, raised about $50 million VC, and went IPO in 2021.
Congratulations. That's very exciting.
Yeah.
So then, since 2021, yeah, what happened from there?
So I didn't stay in the company for all the way to to the IPO. I actually left the company after 4 years working there, and I joined University of Alberta. Main reason was I went all the way from the concept design to even UL certification of that product. But after that, it was mostly engineering tasks to modify it, to improve it, and all those things. I was not much interested in that phase. Had so many other ideas that I wanted to explore. So I came and joined University of Alberta with the same hope that now we can do this similar thing here at the University of Alberta.
Very cool. And then I guess that leads us to the current company, Enerbund.
Yes.
So I guess that's the most current new idea that you're pursuing.
Yes, exactly. So when I came here, I started, expanding my research group. I was very lucky to get so many bright students and graduate students and researchers in my group. We were able to, in the past 11 years or maybe 12 years, we've been able to, do a lot of industry collaborations and projects, and based on what I had in mind before, and also all these interactions with industry and seeing what exactly are the challenges in industry. We the result of all of these research in the past 12 years, all the products that we've designed, they all were licensed to Enerbund, and Enerbund was started about a year ago.
I see. So you said there's a lot of products. Is there a core technology, or is it a variety?
Yeah, so it's the idea that we've been trying to solve is the complexity of energy systems when you're connecting sources to loads. We're talking about so many different things. The sources, let's say solar, diesel generator, you may have grid as a source, you may have energy storage components like batteries, new energy storage like EVs. These are all different components you may have in a house. But then the loads, when you're talking about the loads, you have all types of loads, the heating systems, lighting, computers, and other types of loads that you may have remote locations, you may have medical emergency type loads that each one of these loads that I'm talking about, they need certain features. For example, a heating system doesn't care if the power voltage is up and down or changes the shape. The quality of power is not important. It's just the energy that we're transferring to that load mostly is important. But when you're talking about lighting, for example, if the voltage or frequency fluctuates, then you can see it. So it's you cannot have a low quality or a source that gets interrupted when you have a light. For computers, it may get more serious. Then you can't have any interruption, because then you'll have all these restarts and you may lose data and all those things, right? So each one of these loads and applications, they need certain features and certain requirements and desired aspects. And the source is also the same. They have different things.
That makes sense. So then in that case, what existed in the past? Because we've had light bulbs for a long time. So how did they manage this problem in the past?
So what they've done, for example, what we did in my previous company, Spark Systems, where we were doing that PV, they have some assumptions. Make it simple. They say, okay, if the grid is there, you have PV, inject as much as you can to the grid. So the assumptions are like the grid is infinite load, so that you can inject whatever you want to the grid, dump whatever energy and power you have on the grid. But now if the load is there and the grid is out for any reason, you have all the facilities, you have the PV, you have the load, but you cannot provide the power to the house.
I see.
So now you need some sort of energy storage. So the next generation, they solved this problem that they added batteries to the house so that when the grid is out, you can still power up your load, especially let's say lights or sensitive loads, so you don't lose power, right? So now as we go to each one of those applications, you can see that conventionally we are facing with products that they specifically focused on that application and that assumptions. And as soon as you go out of those assumptions, or something changes in the system, then either the system will stop operating, or you may need some a special additional component to the system so that you can provide that support or that operating modes. So what we're trying to do to solve is to actually remove this requirement, so that the building blocks that we have are actually adaptable to different case scenarios. So if the PV is there or not, battery is there or not, diesel generator, so all of these sources which have different intermittency, so how much they're available, how much they cost, how much pollution they create. So you may or may not want to use those sources for different reasons. And the loads also have their own requirements and everything. So now we're building these blocks so that you can actually connect them, and these blocks are smart enough so that they can actually adapt to different case scenarios, right? So for example, our building blocks are more compact, and they're more optimized so that you can also take them and use it as a portable energy systems. So each one of these design aspects that we're adding to the system, they bring a lot of challenges in terms of implementation, and they also bring a lot of advantages for specific applications. So we try to optimize that building block so that it can actually be used in different case scenarios without the need to go through this whole design installations and costly upgrades if you need to add a component to your system.
Okay, so that makes sense. And then in the real world now, what can you do for a regular person with this product?
Sure. So, for example, if you right now go to want to install PV
And
in your
PV is solar panels?
yes, photovoltaic systems like solar panels on your house, normally you're facing either a $20,000-$30,000 investment, or none, right? Or you can't do anything because the whole system is lots of PVs on the roof, inverter converters that you have to purchase, the installations, everything's super expensive, and you're gonna go with full house installation and full equipment. What we're proposing is you can do gradual expansion. You don't need to go full power.
Okay.
And the basic with this approach, you will have two very good advantages. First of all, you wouldn't need a very large investment. You can gradually expand based on your resources, and also you can see what exactly would be the benefit. In many cases, people don't know if they invest $30,000, what actually they're gonna get. There are some basic calculations and estimations predicts that the companies can give you, but normally those are all, based on a lot of assumptions. But if you can start with a small system, like let's say 2 kilowatt PVs, a few installation on the roof, and a small inverter in your house, then you would know what would be, the output of this, and then you can do your math, or the system can do that math for you intelligently to say, okay, in this location with your case, what is the actual, return on your investment if you actually go full power?
That makes sense. So then, why can't people currently start with small systems? Where do they run into issues?
So because of all the way manufacturers are actually tackling this energy conversion system, they are either going full scale, like 10 kilowatt, 15 kilowatt unit,
Yes.
or the smaller units that they have, you cannot easily expand it because of the installations and everything, others, expenses that they have
Yes.
on the side. What we're doing is, because we're doing it like based on those building blocks, and with those building blocks being very light and small,
Modular as well?
modular
I
as
see.
well, we're doing something like a plug and play type installation, and then you can use that, the same system, you can just detach it and take it to your campsite, use it as your energy storage there if you want, and bring it back, put it in the house, and then it gets connected to your PVs, right? So with this, you can actually start with a small system which can be used for other type of needs. For example, many people purchase these type of like portable energy storage systems for other reasons, right?
Makes sense.
Now I can say, okay, use this one module and a little bit of PV panel, a little bit of a storage, and then you'll see what the system is if you need to expand in terms of PVs or a storage. Maybe you need more storage, or maybe you need to add a port to this modular system and connect it to your EV, and then get the energy from EV instead of expanding for your battery if you don't, want to invest too much on the battery on the side for your house. So exactly depending on your need, you can just move and scale the system as your need changes, or your understanding of your returns of the system is.
All right. So now tell me about like the traction and progress. So now you said you have a few different products and applications. Like, have you made any sales or anything like that?
Yeah, so this, building blocks that we've prepared, they got some, unique applications. For example, there was this company who was asking us to design something for their diesel generators, to make their diesel generators operate better. And then we eventually, one of the product lines that we have is actually this specific application, that we can add these energy storage systems that we have designed and add it to any kind of like diesel generator, existing diesel generators. You can just, with minor modifications, you can add this to the system, and then you'll have this smart system which can control the diesel, operate the diesel at its best efficiency point. So normally diesel generators are sized based on like the maximum power, but they're operating at a fraction power. For example, powering up a few lights. In many construction sites, you can see that, right? So those diesel generators are actually operating at like 2, 3, 4% efficiency. So you're burning all the fuel, but you're getting like 2-3% output from that source. So what this does is turn on the diesel operated at full power instead of like a fraction. Now the diesel will be operating at full highest efficiency that it can provide, like 40%, 50%, and we store it. We store that energy in our energy storage and then provide it back to the load, right? So because of the way we're designing this will provide uninterruptible power source to the load. So the load, if you have, let's say, security systems that you never want to restart, or if the lights are the heating systems may be very sensitive and you don't want to lose those. So in many cases they have these problems with the diesel generators, even though they don't care about the efficiency, the maintenance, the pollution, the reliability, all of those. So this additional component will fill all of those problems, will address all of those problems. And we've been installing a few, we have installed a few for a few customers who have remote diesel generators, which was taking a lot of commute to fuel it every time, so that they've seen 10 times reduction in maintenance, in fuel consumptions and all those things, and no interruptions for the load. That's also very important for them. Recently we have installed a few for Amazon construction sites. They also have a specific requirements for a cubicle they have there. They don't want to lose power or have any interruptions in the load.
That's very cool. Wow, that's exciting. So then now, what do you see the company doing in 5 years, in 10 years? If you keep this up, do you think every diesel generator will come standard, or this will go into every house, or and what can that do on a big scale?
So the concept we're trying to develop is how we can make a perfect building block, so that it's so versatile that when you put them together, it can manage the power, how we call the concept power routing. So energy was conventionally through this recent industry developments are managed like energy, but the power is the difficult part to manage, because power means how I can control the flow of power to the load and provide a quality power to the load. And also when the sources are changing, the cost is changing, the availability changes, the load doesn't see anything. So this is management of power, right? Yes. So this is more like a control problem, because we're talking about milliseconds and microseconds up and down in the voltage and frequency. But the management of energy, which was done before, it was more like resource management. Do I have enough fuel there, or do I have enough energy stored in the battery, right? So with our concept, we can actually manage the power, route the power in the most optimum way, and with whatever is available there, right? Yes. The resources or the loads. So this, you can expand it, from the house case that I explained, you can expand it to neighborhoods. So this can solve the problem of working a few inverters together automatically when the grid goes out, and then they can power up an islanded microgrid now. Yes. So this again can resolve industry peak shavings, because industries would pay for very every time they go high peaks in energy consumption, then, and this is again power problem, right? They peak the power, and then with that they will be paying 1 year for that one time peak that they actually used. So this can actually shave that peak automatically, so they would never reach those high peaks anymore, and they can just scale it as much as they go, as their need go, as their load increases, and always make sure that they're actually not paying excessive amount of money to for the access to to the grid and utilities, right? So again, energy storage systems for grid scale, that's another extension that has a lot of challenges. Again,
Yeah.
with our concepts, we can solve those.
So you really can build this smart grid that's smart all the way from like the largest grids to individual houses or components within houses to make the whole system more efficient.
Exactly.
Wow, so
Yeah.
there's lots of potential there. Lots and lots of potential.
Lots of applications, and this all comes down to how you're optimizing the converter building blocks and how you can make it distributed control instead of central control. So each unit is smart enough by itself so that it can manage the power and energy, but they all work collaboratively for whatever purpose of the system.
Makes sense.
Yeah, and when the system changes, these units should be again smart enough to adapt to new cases.
Awesome. Wow. That's really exciting. So then what are you looking forward to now in the next few months, in the next year, like in terms of development, in terms of the company's growth?
Yeah, well, for each applications, one of the challenges is compliance with standards.
Yes.
So, for example, for residential application, as soon as you want to connect to the grid, inject power to the grid, you have to pass certain UL certifications for North America. So we're going through that process right now. It's because it's one of the things that we've been looking at from day one because of my experience in the previous company, that we have implemented everything according to what the standards needs, but now is the time that we have to go through all the tests. It's a very lengthy process. It's about most of the time it takes a year to
Okay.
do the full test of the system, and hopefully we can shorten that with all the developments that we've done, and then we can hopefully with fundraisings and other collaborations that we can have, we can actually implement all of these ideas in a larger scale for different applications.
Makes sense. Oh, wow. That's really, really great. I'm excited to see where it all goes and have
Thank
one
you.
in my own house.
Sure.
All right. Well, thank you so much again for coming out. And yeah. Ooh, one last thing. Okay, we'll cut out that thank you so much because I forgot. Oh, yeah. And one last thing I wanted to ask you is about the incubator here. So you are one of the members of the incubator. And yeah, tell me about your experience being able to be involved with the mentorship and the resources they offer.
Yeah, so I was not aware of the incubators in the past so many years that I've been here. Just recently, someone told me that there's this facility, there's this opportunity that you can go to and get help. So we do need a lot of help in terms of business developments and commercializations and fundraisings and all those things. I've been in touch with a few mentors here in the incubator. I'm very excited to see how these things can help our business and also change our focus in toward the a more realistic way of presenting these ideas, or focusing on a specific products that they have more potential in terms of commercialization. So we've been in touch with the members, and hopefully in the next couple of months we'll see a lot of those in the mentorships and everything, resulting some sort of like tangible outcomes like funds, fundraisings, and other things.
Amazing. All right, thank you so much, Ali, for joining me here and telling us more. And yeah, looking forward to see where you go.
Thanks a lot. Thank you very much for the opportunity.
Of course.